Good morning, good afternoon, good evening, wherever you may be watching this video from. This is Cornelia Subinda with another video. And now we are finishing off this 2024 paper 2 GCE. I was away for quite some time trying to get some things in order, but now let us move on with our series. Okay, so as you can see, we remained with question 11 and question 12. Let me show you. That is, this is just the first page. Then this is the, as you can see here, question 11 and then question 12. Yeah, these were quite involving questions, as we're going to see during our answering. Okay. Let us start with question 11. A cuboid has a total surface area of 180 centimeters squared and is such that its height 8 centimeters and such that its height is 8 centimeters and its base is a square of side x centimeters. A, they want to show height h centimeter of the cuboid is given by h equal to 90 minus x squared, everything divided by 2x, 3 marks. Then express the volume of the cuboid in terms of x, 3 marks. And hence determine as x varies the maximum volume, 4 marks for that one. Let's start with showing that h is equal to 90 minus x squared, everything divided by 2x. We know that the total surface area of this cuboid is 80 centimeters squared. What are we going to do? What we can do is, first of all, let us find the area of this face here. We can look at it like this. The face that you are currently looking at is this one in front here. So we can find the area of this face here. Okay. It means that we are also finding the area of the face behind, which is that one there. I would rather not shade it. I'll just leave it like that. And then there is this one at the side that we are also looking for. Hope you can see it. And then we're also going to look for the one at the top, which is the one that is here. Okay, so that's what we are going to do. Let me just clean up because it will be confusing. At your own convenience, you can do just that. So let us start with the square base. You can see there's a square down, there's a square up. And then the area of a square is what? X squared. We are finding the total surface area. Okay. Question 11a. So we are going to say 11a. 11. Sorry for that. Okay, question 11a, where we know that the total surface area is equal to what? We have 2 times the area of a square, which is x times x. Let me just reduce my font a bit. I think it won't fit if I'm writing like that. Sorry for that. So question 11a, well, we know total surface area is equal to 2 times area of a square is x times x, plus we have a particular rectangle here, the one that we can see just in front. We have the height h, total height there is h, and then the length we can see is x, so x times h. And then there is another one behind, so I'm going to say 2x times h plus 2 open bracket. And then there's this one at the side, where we know that the breadth there is x, the height is also h, so it's also 2x times h. X x times h, like that. To continue, we're going to have x times x is x squared, like that, plus x times h is just xh, plus x times h, just hx. And then to continue, we group the like terms together. We are going to have is equal to 2x squared, plus x 2hx. Sorry, I forgot to add them properly. 2hx plus 2hx is 4xh, and then that will be a total surface area. And we know that total surface area, given in the question was 180 centimeters, where we can go back and confirm 180. And as we can see in the expression for h, there is no, or let me say it like this. In the expression for h, just want you to express h in terms of x. There is no h on the other side of this particular equation. I'm talking about this one here. Yes. So because we can't see h on the other side, we make h a subject, right? First of all, let's do this. We're going to say 2x squared plus 4xh is equal to 180. Then at this point in time, we can simply divide by 2, because we can reduce by 2 every term by 2. Okay, 2 can go into itself. 1 into 4 it's 2, into 180 is 90. I'm going to have x squared plus 2xh is equal to 90. Yeah, so let's make x subject. First of all, we take whatever is not having the normal procedure, and then we are going to divide this by 2x, right? 2x. So everything that's this side also divide by 2x, like that, and then h will be equal to 90 minus x squared divided by 2x. We can confirm 90 minus x squared divided by 2x, that is our h. And then we can even conclude, therefore h is equal to that, and then we can say hence what? Hence shown. Yeah. So that would be our answer to part question A. Then we go to part question B, right? Given that, I went to question 12. Express the volume of the cuboid in terms of x. This one is only 3 marks. It's just because because of how simple it is. So B. So look at the language in terms of x. So in the volume of the cuboid, it shouldn't have anything to do with h. Volume of the cuboid we know is length times breadth times height. Yes. Well, we know the length of the cuboid in this particular case is we can just say the length is h, the breadth is x, the height is also x. We can confirm. So you can take this h as the length, but let's just look at it the way it is. This x can also be your length. So what am I saying? If you were to flip this this cuboid nicely, this h would be your length, that would be your height, your x, and then the breadth, like that. But whichever order you would want to look at it to arrive at the same answer. Yeah. So it's x times h. Okay. So let's do just that, which is equal to x times h. X squared h. X squared And then what is our h? We found an expression for h, which is 90 minus x squared divided by 2x, like that. This is our expression for h. And then yeah, we can simplify. We can simplify because they just want you to find the volume of the cuboid in terms of x. Yeah. So x can go into itself a 1, it can go into x squared, x times. So we distribute the x in what has remained in the bracket. We are going to have 90x minus x cubed as our volume, which is equal to 90x minus x cubed. Yeah. So therefore volume is equal to 90x minus x cubed. Yes, so that's what they wanted you to do. You know, if you want, you can even do it like this, which is equal to 90x minus x. Yeah, I put squared. I'm so sorry for that. You know, I was saying something else, but I'm writing something else. Okay, let's go back. We can say therefore v is equal to 90x minus x cubed. Yeah. Others would want to say is equal to 90x minus x cubed. And they put this in brackets, centimeters cubed. The others want to say that, and I don't think there's anything wrong with that because we're given the units in the question, right? We're given that it is in centimeters there. Yeah. Hence, determine as x varies its maximum volume. Maximum volume. Maximum. Okay, when I say maximum, is something ringing in your head. If it's not, then there's something wrong with you. You need to. Okay, there's nothing wrong with you. Just need to sharpen your calculus skills. Maxima and minima is a topic, right? The subtopic. They say maximum. It means they want you to differentiate something, right? They want you to find the maximum volume if x varies. So we know that v. This is C. We know v is equal to 90x minus x cubed. Maximum volume will be found when you differentiate the volume, then you set the derivative equal to x. What do I mean? I simply mean dv, and then the variable in question is x. So dv x is equal to what? 90 minus 3x squared. So 90 minus 3x squared is your dv dx. Now, when dv dx is equal to 0 is what we are considering. We say when dv dx is equal to 0. Yeah. So we have 90 minus 3x squared is equal to 0. So at this particular point, we can take the 3x squared to the other side. Where is it equals 3x squared to the other side? We divide by 3, divide by 3. That can go into a 1, and then into 3, it's also a 1, 2 itself a 1, into 90, it's a 30, right? So x x squared is equal. Wait, what am I? Am I finding the value of x? Sorry for this. We are finding the maximum volume. The maximum volume. Okay, maximum volume is found, at this particular point. So we have x squared is equal to 30. So this value of x when dv dx is equal to 0 is when you find your maximum volume. So we are going to have a value of x, which is square root of 30 plus or minus square root of 30, right? So x will be equal to plus or minus square root of 30. Yes, and then of course we have that expression for dv dx, and if you look at dv dx, we can find the second derivative. Okay, and they want us to find the maximum volume. So which one will give us maximum? Which value of x will give us the maximum? So we have two values of x, plus or minus square root of 30. Sorry for that. So I have two values of x plus or minus square root of 30. And then we need to go to, of course, our dv dx. I hope you can see. Can you see it? It's there. We differentiate it again. Let's use the second derivative test. The 2v then dx2, which is equal to what? If you differentiate this function again, derivative of 90 is 0, derivative of 3x squared is 6x. If we substitute the positive square root of 30 in the 2v dx2, we are going to have a being greater than 0, and if a is greater than 0, it means that it is a maximum. But if you substitute negative square root of 30, we are going to have a being less than 0, and if a is less than 0, it means it's a minimum. I hope that makes sense. Of course, some of these things are really hard to understand. Really hard to understand. So what do? We write them out. What I mean is we're going to say that when what? X is equal to square root of 30. Let's put a comma there so we don't get confused. When x is equal to square root of 30, the 2v dx2 is equal to what? I hope you have a calculator. It is 6 times square root of 30. 6 times positive square root of 30, right? We're going to have 32.9, 3 significant figures. And this value, this value right here, let's use the green one, is what? We can call its a is what? Greater than 0. That's what I was meaning. I hope that makes sense. Just wants to remove any queries, and then we can safely say when in the exam you don't need to show all this work. This is just for the sake of explanation. When x is equal to negative square root 30, from there you can simply say that the 2v dx2, if you substitute 6 times negative square root of 30, you just need to put the negative number there. You're going to have negative 32.9, and this particular value here will be called a. We'll call it a, and here we'll say a is less than 0, and the particular curve that it would represent is it would look something like if it's greater than 0, that particular at the stationary point, that's how it would look. Okay, that's the nature of the stationary point. Now at this particular point here, for this one being less than 0, sorry for that, I made a mistake. For being greater than 0, it will be positive, it smiles, right? And then for being less than 0, it's of course negative. Like the word negative, negative. Yeah, that's why it's also. Yeah, so the value of v is what? We haven't found out. We haven't even answered our question. I was just busy trying to explain. This is better to leave no stone unturned. So, to leave no stones unturned. So, So let's go back to black ink. We know what our value of v is. What is our v? V is equal to 90 times x. 90 times, this is square root of 30, positive square minus square root of 30, which has to be what? Cubed. Because it was 90x minus x cubed. Therefore, v is equal to maximum volume will be what? We have 90 multiplied by the square root of 30, then minus the square root of 30, which has to be cubed. We're going to have maximum volume, correct, to 3 significant figures, 329 cubic centimeter, 3 significant. Okay, we'll just shorten it. 3 sig figs. But in the exam, it's not recommended to use sig figs. That can mean anything. So it's just better to write 3 sig. That's if you have time to do all this. But it's just better just write 329, and we understand what you mean when you write 329. So 329 centimeters cubed would be your final answer for the maximum volume of the cuboid. I hope it's clear. If it's not, I don't know when it can be clear. Yeah, because I've tried to simplify it as much as it can be simplified. Yeah, so that's your answers. Those are your answers. 10 marks. 10 marks. Question 11. Take note. 10 marks. This question. Okay.